初めてできた友達は無口だったけど、いつも一緒にいてくれた。席替えで緊張したのはきっと初めて恋をしたから。
The Progression Group 2. What is sequence and series? A sequence, it's called progression in British, is ordered number of lists. Numbers in this list are called terms. For series, is actually the value when all of the terms of the sequence are added. This value is known as sum. Example of a sequence is, here we can see that the sequence of odd numbers are 1, 3, 5, 7, 9, and so on. While an example of a series is, for the odd numbers, 1 plus 3, plus 5, plus 7, plus 9, and so on. Fun fact, did you know that sequence and series can be arithmetic, geometry, or linear? And did you know that Johann Carl Friedrich Gauss actually discovered the arithmetic sequence when he was only in elementary school? Pretty amazing if you ask me. Finite and infinite sequences. An infinite sequence means that it continues forever. A1, A2, A3, A5, A6, AN, and so on. As an example, a sequence of multiples of 10, 10, 20, 30, 40, 50, 60, and so on is infinite. It is shown by adding the triple dots at the back. While finite sequence has a fixed number of terms, A1, A2, A3, A4, A5, A6, and last but not least, AN. An example given is a sequence of 2-digit square numbers, 16, 25, 36, 49, 64, and 81. Is finite as there are no triple dots at the end of the sequence. The partial sum of a sequence series is given the sequence T1, T2, T3, T4, Tn, and so on. The partial sums are for S1 is equals to T1, the first partial sum. For S2 is equal to T1 plus T2. And S3 is equal to T1 plus T2 plus T3. For the n partial sum, we observe that Tn is equals to Sn minus Sn minus 1. The relationship between sum and actual values can be shown by this. Arithmetic sequence is actually a set of ordered terms of the form where A plus D, A plus 2D, A plus 3D, and so on, where A is the first term and D is the common difference. And term of a sequence, we can see that Tn is equals to A plus bracket n minus 1 bracket D, while sum of the first term is described as Sn equals to n over 2 bracket 2A plus n in the bracket minus 1 in the bracket D. By letting the last term L equals to A plus n negative 1D, we can get that Sn equals to n over t in the bracket A plus L close bracket, where Tn equals to the n term, A is the first term, n is the number of terms, D is the common difference, Sn is the sum of n terms, and L is the last term.
SPM question 2010 and 2011. Now we have to analyze the question given. The sum of Sn of the first n term of an arithmetic progression is given by Sn equal to Bn plus Qn squared. This is Sn. And the sum of the first 5 term is S5 equal to 40, while the sum of the first 10 terms is S10 equal to 155 respectively. The question asks us to find the value of P and Q. Hence, find the first n term of the arithmetic progression is Tn, and the value of the first term T1, and the common difference D. We're gonna substitute this into this and S10 into Sn. All I have to do is substituting the n values into the equation given. So we got S5 equal to P multiplied by 5 by Q multiplied by 5 squared. Make sure you put the bracket so that you won't make any mistake when you're substituting the value. And we get the value of 40 equal to 5P plus 25Q. The same goes with S10. Substituting the 10, make sure you put the bracket into the equation, and we get 155 equal to 10P plus 100Q. I used the method of elimination method to solve the linear equations. So what I'm going to do is eliminating one of the unknown. Here I choose to eliminate the value of Q. So what I need to do is I have to make the coefficient for Q the same. Here we see that the coefficient of Q isn't the same. So what I have to do is by multiplying the first equation with 4. And we get 160 equal to TP plus 100Q. And we're gonna eliminate the value of Q. We subtract equation 3 with equation 2. To eliminate the value of Q, we get 5 equal to 10P. As we simplify this, we get the value of P equal to 1 over 2. So we're substituting the value of P into the equation 1, move the Q to the left hand side and move 40 to the right hand side, and we got Q equal to 3 over 2. As we already done this question, we make the conclusion P equal to 1 over 2 and Q equal to 3 over 2. Next question. So based on the question A before, by substituting the value of P and Q into the equation given, we get the equation of Sn equal to half n plus 3 over 2n squared. We're going to find Cn by using this equation. As we already know, Sn equal to Sn 1 over 2n plus 3 over 2n squared. All we need to do is to find the Sn minus 1. To find the Sn minus 1, we substitute the n minus 1 into this equation, and we get Sn minus 1 equal to 1 over 2 multiplied by n minus 1 plus 3 over 2 n minus 1 squared. Here, this is squared for the value in the bracket. We have to solve this first. And we got this one, n squared minus 2n minus 1. So, we solve this. And we get 3 over 2 n squared minus 3n minus 3 over 2. And we simplify this. We get the equation of Sn minus 1 equal to 3 over 2n squared minus 5 over 2n minus 2. So, here we can get the equation of Tn. We substituting the Sn equation into this and Sn minus 1 equation into this, so we get this. And it was better if we put the bracket so we won't make any mistake. Then we eliminate the bracket by multiplying the negative in front into each of the elements inside the bracket, and we get negative 3 over 2n squared plus 5 over 2n plus 2. And simplify it, we can get the equation of Tn. Once we get the value of Tn, we can proceed to find the value of D. How to get the value of D, we have to subtract the Tn with 3n minus 1. We already have the Tn, so we have to find the Tn minus 1. To find the Tn minus 1, we have to substitute the n minus 1 into the 2 here. So put the bracket, put the n negative 1 here. By solving this, 3 multiplied with n, 3 multiplied with negative 1, we get 3n negative 3 plus 2. And then simplify it, we get the 3n minus 1. We get the Tn and the 3n minus 1, so we can find the value of D. Substituting the value here into here, and then we eliminate the bracket by multiplying the negative, the minus sign with Tn and negative 1. And we got negative Tn plus 1. At the end, we get D equal to 3. Now we move on to find the value of A. The value of A is equal to the first term. So we substitute the value of 1 into the n, and we get A equal to 5. As we are done with this question, we make conclusion Tn equal to 3n plus 2, A equal to 5, and D equal to 3.
Given the fifth term of an arithmetic sequence is 1. Based on the formula Tn equal to A plus n minus 1 times D, we will write the fifth term as T5 equal to A plus 4D. Substitute 1 in T5. Express A in terms of D, so we get equation 1. Next, given the sum of the first 7 terms is 14. Based on the formula Sn equal to n over 2, 2a plus n minus 1 times D, we will write the sum of the first 7 terms as S7 equal to 7 over 2 times 2a plus 60. Substitute 14 in S7 and equation 1 in A. Solve the equation and find the value of D. To find the value of A, substitute the value of D in equation 1. The question is, find the sum of the first 4 terms of this sequence. To find the sum of the first 4 terms, we will also use the formula Sn equal to n over 2, 2a plus n minus 1 times D. We already have the value of n, a, and d, so we just need to substitute the value in the formula. Use calculator to find the answer.
Given an arithmetic series. First, find the number of terms in the above series. Second, Find the sum of all terms. Moving on to question 1. To find the number of terms, we will use the formula Tn a plus n minus 1 times by d. To find the number of terms for this series, we have to take the last term as Tn, which is negative 43/6. First, identify the first term, which is a, and the common difference d. This is the a and this is the d. Substitute into the equation and continue with the equation until we get the number of terms. Question 2. The sum of all terms. We will use the formula Sn, n over 2 times by a plus l. The a is the first term and l is the last term. N is the number of terms. Substitute all of the values into the equation and we will get the final answer.
初めて門限を破ったあの日、